Hey guys, in this lesson we're going to be taking a look at our similar triangle theorems. In the last lesson we looked at similar triangles, and in order to show that they were similar we had to show that all three of the corresponding sides were proportional and all of the angles are congruent. Well, in real life when we start working with these, they're not necessarily going to give you all 6 values for the triangles. They're not going to give you all of the angles or all of the sides. They're just going to give you bits and pieces. So what these theorems will do is, given those bits and pieces, if you know the rules, then you're able to show that the triangles are still similar with less information. So the first theorem we're going to look at is our angle-angle similarity theorem. And what this will do for us is, if we've got two angles or two triangles, they can be similar if we can show that two pairs of corresponding angles are congruent or equal. So what that'll tell us is, if we've got angle A and we know it's congruent to angle D, or we can show that it is. And then if we have another one, and it doesn't matter which two they are, they can be any two. So if we have angle C is going to be congruent to angle F. If we can show those two things, then we can say that the two triangles are similar. So triangle ACB would be similar to triangle, and we got to make sure we line everything up correctly, DFE. And it could have been those two angles, it could have been those two angles, and those two angles. Just as long as they correspond with each other, you can use the angle-angle similarity to show that they are similar. Looking at the next one, you can do side-side-side similarity. So what that means is, you would have to show that this side here is proportional to that side there. So AC over DF, and then you would have to figure out what that ratio is, and then you would have to do CB compared to FE, and then you would have to do AB compared to DE, and if you're able to show that all three of those ratios are equal, then you can say that the triangles are going to be similar. You don't have to know anything about the angles at all. If you're able to show that all the sides are proportional, you can say that triangle ACB is similar to triangle ACBDFE. So for our third one, our side-angle side similarity, we need to know a vocabulary word that's in the theorem, and that vocabulary word is included. An angle is considered included if it is between two sides of the triangle. Another way to look at it is the angle that's created by two sides of a triangle. So if we were looking at this triangle right here, and it doesn't matter which sides, so like if we were looking at AC and CB, the angle that is included between them is angle C. So we could say angle C is included between AC and A or CB. So if we were wanting to find an angle that was congruent to that one, we would have to use angle F if we were showing similarity. So what that'll look like, doing side-angle side similarity, two triangles are similar if you can show that two pairs of corresponding sides are proportional and the included angles are congruent. So we would have to show two sides. So let's go AC compared to DF. And then let's say we went for side, they gave us information for side AB, and we were comparing that to DE. And we could show that they were proportional. The included angle that they would have to give you information about, and there's no way around you having to use this angle is angle A. You see how angle A is between those two? That's what makes it be an included angle. So you would have to also show that angle A is congruent to angle D. And if you're able to show that the two sides are proportional and their included angles are congruent, then you can say that they are similar based on the side angle side similarity theorem. So we've got triangle ACB is similar to triangle DFE. So if we just start trying out some examples. Looking at the first one, are the shapes similar? If they are, which rule explains why, and what is the similarity statement? So are the shapes similar? That's just the simple yes, no, we can show that they're similar. And then if they are, which rule explains why? And we can use any of these rules, any of these three rules that we have here. So which rule explains why? We've got angle-angle similarity. We've got side-side-side similarity that we could use, and then we also have side-angle-side similarity. And then what is the similarity statement? That's triangle or shape whatever is similar to triangle or shape whatever. So if we start trying these out, looking at those two triangles, they don't give us all three sides, they don't give us all three angles, so we're going to have to use one of our triangle similarity theorems. So it's not going to be side, side, side because they don't give us any information about sides. That being said, it can't be side angle side either, again, because no sides. So that means we have to show by angle-angle similarity. So that tells us that we have to show two angles are going to be similar. So if we look, we've got angle D, and we know angle D is congruent to angle F, or angle V. So angle D is congruent to angle V, and we know that because of the arc marks that they have in there. So then, since there's two arc marks here and two arc marks there, we can say angle F is congruent to angle U. So we've got two angles that we can show are congruent. So angle-angle similarity says two triangles are similar if you can show two pairs of corresponding angles are congruent or equal, and it does that right here. So are the two shapes similar? Yes. Angle-angle similarity, for which rule explains why, and what is the similarity statement? Triangle, and again, that first one that you do really doesn't matter, but if they give you one, you've got to use what they give you. But we've got DFE is going to be similar to triangle. D has one arc mark, so I've got to go with the one that has one arc mark. So V, and then F has two, so U has two, and then E has none, T has none. So there we go. So yes, the shapes are similar. It's by angle-angle similarity, and triangle DFE is going to be similar to triangle VUT. Okay. Taking a look at the next one, again, we're looking at things that just have angles. So if we're looking and comparing, here's an 85, there's an 85. So angle U is going to be congruent to angle D. And then here's a 42, and that one's not a 42. And don't assume right away if what you see, whenever you see the angles that they give you, they aren't the same. This angle could be similar to angle E. So to check and make sure, we need to figure out what angle E is. So we're going to use that triangle sum theorem to figure out what the third angle is going to be. So we do the 85 plus 34 plus the angle we don't know, let's call it x, equals 180 degrees. So 85 plus 34 gives us 119 plus x is equal to 180. Subtract 119 from both sides. And x will be equal to 61. So that tells us that this angle right here is 61. So if we're looking for an angle to be congruent with 42, there isn't going to be one because one angle is 34, the other one's 61, so there's a none. So are the shapes similar? No, they are not similar. If this had been 42, then we would have been able to keep showing by angle similarity that the two are congruent. But since it wasn't, we can't. Looking at the next one, we've got STP and we've got PRQ. And if you look, they don't give us any side information, so we can't use side, 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 or side, angle, side. So if it's going to be anything at all, it's going to be angle similarity. So if we're looking at the two triangles, we've got one triangle right here, and we've got another triangle right there. So if we're writing our similarity statement, they've got angle S right here. Angle S, looking for stuff that's congruent, is congruent to angle Q because those only have one arc mark. Do you see another angle, set pair of angles in there that are congruent? Hopefully you saw those right there. Angle SPT congruent to, and since we started with S, we got to start with Q. Angle QPR. So those are vertical angles, and even though they're not explicitly marked because you've been taught that those two angles are vertical, they're considered fair game for whenever people write problems for you to know that they are congruent without showing you. So, well, we've got two angles, two corresponding angles that are similar. So from there we can say, yes, the shapes are similar by angle similarity. And they want the similarity statement, so triangle SPT is going to be similar to triangle. Now I started with S, and S has one arc mark, so I've got to start with the angle with one arc mark over here. So Q, and then I went to P to the middle here, so P has to come next, and that leaves R that's left. And it's also the one that doesn't have the arc mark, so that's another reason why it matches up with T. Looking at the next example, they can take two triangles and stick them together and have one triangle within another triangle. The easiest way to be able to do these is to see the small triangle on the inside. So you've got this triangle right here, and then the big larger triangle on the outside. And to take those two triangles and draw them as two separate triangles and put the side measures or whatever measures that they give you. So if I draw them out separate, so we've got Q, R, P, and Q to R is 72, R to P is 44, and Q to P is 80. So writing that little triangle is the easy part. The bigger triangle, we've got QST. So if you look, QS is this whole thing right there. So to be able to find the length of QS, we've got to do the part plus part equals total, that segment addition postulate. So 72 plus 36 gives us 108. And then 80 plus 40 will give us 120, and then this is going to be 66. So if we start writing a proportion to compare our sides, we are going to compare QR to QS. So we're going to go QR over QS. QR has a value of 72 over 108, and 72 over 108 will simplify down to 2/3. So QR to QS, and then RP to ST. RP has a value of 44, ST has a value of 66. 2/3 again. and then QP over QT, 80 over 120, and that's going to give us 2/3 as well. So since we were able to say that all three of the sides are proportional, we can say that the triangles are similar based on our side similarity, because that tells us two triangles are similar if you can show that all pairs of corresponding sides are proportional, and since all three of those fractions are equal, we have similar triangles. So yes, which rule? Side similarity. And then what is the similarity statement? Triangle QRP is going to be similar to triangle QST. And that's not the only way you could solve this one. If you look, angle Q is the same angle there as it is there and there. So you could also go side angle side and use that ratio and this ratio and then say angle Q, and you would have to name the whole thing, that way people would know that they were different. You could say angle RQP is similar to congruent to angle SQT. So you could use these two ratios showing that they are equal, and then because these two angles are the same, you can say that they are congruent, and then you would say yes, the two triangles are similar, but this would be side similarity. So that's an example of where it could go either way. Looking at another example, we've got triangle FGH and triangle VUW. So if we're looking to show that things are similar, well, they don't give us any angles, so that rules out. If we make our list again, we're looking at angle similarity, side similarity, or side similarity. So the only thing that we have to use is going to be our side similarity. So we need to match up sides that would be similar. So if we took this FGH and rotated a little bit, this side would match up with that side. So GH would match up with VW, and GH has a value of 99 over VW is 66, so 99 over 66 is going to have a value of, if you put it as a decimal, it's 1.5. And then we could also have FH would match up with UW, and FH has a value of 135 over 90. So 135 over 90 is going to have a value of 1.5. And then looking at the last one, we're going to have FG over UV. FG has a value of 162 over 106. I think that's a 108. 162 divided by 108, and that's going to give us 1.5. So yeah, that's a 108 there. So since we were able to show that all three sides are proportional, we can say yes, the shapes are similar by side similarity, and the similarity statement is going to be triangle GHF is going to be similar to triangle VWU. Looking at the next one, if you look, and with these, they're not going to give you any angle measures. They're not going to give you any side measures. You see those little triangles? Remember they say that two lines are parallel? Well, if those two lines are parallel, then this line is considered a transversal, and this line is considered a transversal. So there's two ways to look at this one. If this is a transversal here, that tells us that this angle right there and this angle right there, if we're looking at this is a small triangle right here and this is a larger triangle right there, those two are going to be corresponding angles. And if you remember from our parallel line rules, corresponding angles are going to be congruent. So there's angles there. Here's a set of congruent angles there. So you can get angle-angle similarity there. You can also get angle similarity right here because, again, angle S is going to be the same as angle S, or angle TSR is going to be the same as angle USQ. So these, and they have to have those little parallel marks. If they don't have those little parallel marks, they're not going to necessarily be similar. So this one's going to be angle-angle similarity. And so we're going to have triangle TSR is going to be similar to triangle, and the angles that correspond with each other are going to match up in the similarity statement as well. So USQ. Looking at the next one, they give us sides and they give us angles. And remember, this kind of works like a rotation. So that means that side IK, if we rotate it, would match up with GK. So IK has a length of 162 over 180. So comparing it to that side right there. So that part compared to that part. So 162 divided by 180 gives 0.9. And then this part right here goes to that part right there. So JK over HK. So JK is going to be 200 over 180. So 200 divided by 180 gives us 1.11. So looking at these, because their ratios are different, they're not going to be the same. They're not going to be similar. So no, not similar. If they had worked out, then we would be looking at this angle right there, and it would be side angle side similarity. But since this ratio is not the same, oh, I did this backwards. Did you see me double checking that? So looking here, I went the top triangle over the part of the bottom triangle, so I should have done HK over JK. Just JK. HK is going to be 180 over 200. So 180 divided by 200 is going to give you 0.9. Okay, so now they're the same. So now we've got two sides that show similarity. Well, if we look at our list of options, we've got angle-angle similarity, side-side-side similarity, or side-angle-side. Well, we can't do angle-angle because they don't give us information for two angles. Can't do side-side-side because they didn't give us information on these two sides. So then our only other option is side-angle-side. And remember that vertical angle rule? They're using it again. So we're doing angle IK GKH is going to be congruent to angle, and since I started with I here, and it's the part that matches up there, and we rotate it, it would be G, so GKJ. Since we're able to show that two sides and their included angle, notice this was between the two sides. If this wasn't between the two sides, this wouldn't work out. We're able to show, yes, they are similar by side angle side similarity. So triangle, and if you're very careful and you write the angle names correctly, you can just take these angle names and use them for your triangle similarity statement, but I would always go back and double check. It's going to be similar to triangle GKJ. Alrighty, and looking at the last triangle, this is an example of a triangle where it's kind of similar to this example that we did, but with this one you're not given the lengths of the side. So it's another one where you've got to compare little triangle to bigger triangle. So I'm going to draw the triangles over up here and do the math down there. So if we're looking at the little triangle, there's the little triangle on the inside. And SW has a length of 96, ST has a length of 84, and we don't know WT. But we know that angle S here is going to be the same as the one in the other triangle, in the bigger triangle. So there's our bigger triangle right there. So bigger triangle, and the points are going to be called S, and I'm going to show that they're the same so I don't forget, and then VU. So in order to know the length of SV, we have to do the segment addition postulate. SW plus WV equals SV. So 32 plus 96, 128, and then ST and UT, so 84 plus 28 gives us 112. So if you look, they don't give us that side. So if you look at the information that they give us, they obviously give us a side, two sides, and an angle. We just have to double check and make sure that the angle is included between the two sides. It is, so it's going to be worth our time to do the math to check and see if they really are similar. So let's start with our sides. So we're looking at VS over WS. So 128 and WS is 96. So 128 divided by 96 is 1.3 repeating. And if we do US compared to TS, US is going to have a length of 112. TS is going to have a length of 84. If we divide that out, that's going to be equal to 1.3 as well. And by the picture that we showed that angle VSU is going to be congruent to, and I went VSU, so I've got to make sure I go WST. And it is included between those two. So yes, we can show that the triangles are similar by side angle side similarity. And our triangle similarity statement is going to be, let's go triangle VSU is going to be similar to triangle WST. So there's just some good examples of the three different similarity theorems that we have: our angle-angle similarity, the side-side-side similarity, and the side-angle-side similarity theorems. If you have any questions, be sure to write them down on your paper and ask when you get to class.